Hello friends, in today's question, an inductor L and a resistor R are connected in series to a battery of 15 volt EMF in a circuit as shown below. The key1 has been kept closed for a long time. Then at t is equal to 0, K1 is opened and key K2 is closed simultaneously. At time t is equal to 1 millisecond, the current in the circuit will be. So this is our circuit. So we have an inductor and a resistor which are connected in series, and initially it is given that key1 was closed and K2 was open. So under this condition, the steady state current will be flowing if the key1 is closed for a pretty long time. So we can find out easily that current, because at steady state condition, the inductor will be acting as a short circuit. And after some time, key K1 is opened and simultaneously key K2 is closed. And at that condition, L and R still in series, but now the voltage applied EMF is out of the picture. So we can easily find out, because now the current is going to start to decay exponentially based on the decay coefficient of this inductor. And then we can find out the current at t is equal to 1 millisecond. So let us start. It means this question consists of two cases. Case 1, when K1 was closed, K2 was open. And the second case, when K2 is closed and K1 was open. Or we can also describe that when K1 is closed, we can call that as a steady state condition. So let us start from there only. So you can say when K1 is closed and K2 is open. So under this condition, we have a steady state condition. So steady state condition basically means that our inductor will be acting as a short circuit. Inductor behaves like a short circuit. Behaves like a short circuit. And the switch is flipped at t is equal to 0. So let us consider condition a time which is slightly less than at t is equal to 0. So we can say for t is equal to t negative. So this basically means that our you can say t is just before t is just less than 0, fraction of second. So we can denote it as t0 negative. And under this condition, we have a steady state condition and inductor is going to behave like a short circuit. So we can find out the current. Let me draw the figure here. So this is our inductor, which is going to behave a short circuit, and we have resistor. This is open, and we have a battery, and we have that our K1 which is closed. So therefore we can find out I steady state current. EMF is given as 15 volt and value of resistance is given to us as 0.15K. So the current that is flowing in the circuit, let us call that IS, means steady state current. So we can easily find out that current. So we can say current IS can say the steady state current which we said, let us suppose is IS, will be equal to the voltage V and divided by R, that is our resistance. Voltage is our 50 and this is 0.15 k ohm. It can be written as 150. So therefore we get our steady state current is equal to 0.1 ampere. And at t is equal to 0 exactly, the case is reversed. Case means the keys are now reversed. This was our K1 and this was our K2. So therefore we can say that at t is equal to 0, K1 is now opened and K2 is our closed. Therefore we can just redraw the circuit, and now the circuit will be like this. This is our K2 and this is our battery, and we have K1 opened. So we have K2 and K1. This is applied EMF of 15 volt, inductor, and we have resistor. Now as soon as K1 is opened and K2 is closed, the inductor is going to resist any change in the current. The inductor will resist any change in the current. Resist any change in the current. So now we can analyze that R and L will be connected in series. So we can say R and L connected in series. So we can find out their time constant for a RL circuit, RL series circuit. So we can say time constant for RL series circuit, which is given as tau, and that will be equal to L upon R. If we substitute the value, inductor is given to us as 0.03 and it is 150 ohm, and this can be written coming as 0.2 millisecond. So this is the time constant for RL series circuit. Now because of the inductor present in the circuit, the current is going to decay exponentially, and which can be also written in the form of the equation. So we can say the current in the RL series circuit decays exponentially which can be given as I of t is equal to I initial, let us call that as II e raised power minus t upon tau, where this II is the initial current. And II is the initial current at t is equal to 0. Initial current at t is equal to 0. And we just found out the value of this I initial current is our steady state current. So this is our current at t is equal to 0, which we are calling as I initial. So we can say that the initial current in the circuit, the initial current in the circuit before t is equal to 0, which we wrote as t is equal to 0 minus, is the steady state current. Is the steady state current. So we can write that our I initial is equal to I steady state, and which is our 0.1 amperes. Now we are supposed to find out the current at t is equal to 1 millisecond. So we substitute in this equation. We can write at t is equal to 1 millisecond, I1 is equal to 0.1 e raised power, we have this as 1 millisecond, divided by this tau we just calculated is 0.2 millisecond, and this can be written as that current at 1 millisecond will be equal to 0.1 e raised power minus 5, and this e raised power minus 5 is approximately equal to 0.067. So if we substitute the value of E, you can write the current at 1 millisecond will be 0.1 multiplied by 0.0067, and this comes as 0.00067 amperes, and it can be written as current in 1 millisecond will be equal to, in the form of a millisecond, 0.07 milliamperes. So the current at 1 millisecond is 0.67 milliamperes, and the options that are given to us, we can say option number C is the correct option. Option C is correct. This completes the question. Thank you.